All right, in this video, I'm going to discuss how to calculate a confidence interval for a population mean, okay? And I have a small sample size here. So it's going to be a T-type confidence interval, all right? Okay, so let's start by talking about what is a confidence interval in general. Like, what's the main idea here, okay? Well, I have a sample of cars, right? So I've gone out and randomly collected this data set here. And in particular, right now, I'm interested in their price. And I want to know something about the average price of cars in the population. All right. So I have a sample average, X bar. Right? X bar, remember, is from the sample. And in general, one of the reasons why we collect samples is because we want to know something about the population, right? There are millions, trillions, I don't even know how many cars there are out there right now for sale, right? And if I wanted to figure out all of their prices, the price of all the cars, and that would give me the population mean, mu, right? That would give me the population mean. If I were to go out and collect all of the prices of cars that possibly exist right now, right? That would give me the population mean, mu. Of course, I can't do that. That would take me forever. So instead, I've collected this sample, right? And the sample, let's suppose it's a random sample from the population. So I want to use this sample mean, X bar, to tell me something about the population mean, mu. Okay? Now, what are the chances that the population mean is exactly the same as the sample mean? Probably pretty slim to none that these guys are exactly the same, right? The sample mean has some sampling error in it. And so it's not going to be equal to exactly the population mean, right? The sample size is one consideration for why the sample mean is not exactly the same as the population mean. Remember, the population we don't even know how many observations, has a lot of observations, versus my sample only has 10 observations. So these are not going to be equal to each other. So instead, this is the idea behind confidence intervals. I basically am going to create a buffer zone around my sample statistic. And then I'm going to say, all right, you know what? I'm 95% confident that my population mean is somewhere in that buffer zone. Okay? So whatever level of confidence I have. So 99%, whatever level of confidence I have, that's how confident I am that my population mean is somewhere in that interval. Okay? And so how do I create that buffer zone? Basically what I'm going to do is I'm going to calculate a margin of error, E. Then I'm going to travel that X bar minus E. That'll tell me the lower side. Right? And then I'm going to take X bar, and I'm going to add on that margin of error, E, and that'll give me the upper side. All right? So that's the basic idea behind confidence intervals. Okay, so let's start by going and calculating the confidence interval for this price. So let's start by figuring out what is X bar, the sample mean. So equals average. Excel will tell me the average, the mean, sample average. Okay, click on my data, hold my clicker, drag down, release, E2 to E11. So we see it's E2 to E11. You see this little colon there, okay? And I could have, it automatically closed the parenthesis for me. Okay, very good. Press enter. And there we go. There's our sample mean. Okay. Next, I'm going to need to know the sample standard deviation. So let me go ahead and write that down. Sample standard deviation equals STDEV dot. Now we see Excel is going to start recommending functions for us. Dot S is the one I want to use because this is a sample standard deviation. Okay. Click my top observation, hold my clicker, drag it down, release, close parentheses, and press enter. Okay. Another thing I'm going to need to know is the sample size, N. Now, you can always just write, okay, well, this is 10. We know it's 10. You could also use the formula count. And count, especially, it comes useful when your sample size is much larger and you're not exactly sure how many you have there. But basically, it will count the number of observations you highlight. So it'll tell me 10. Okay. All right, next thing I want to write down is my confidence level. All right, my confidence level. Let's start with a 95% confidence. So go ahead and write that as a decimal, so 0.95. All right. The next thing I want is alpha. Alpha is basically your error, right? So if I'm 95% confident, then I'm accepting a 1 minus whatever 90, so 1 minus 0.95, right? So use cell references here. So this will help it. So if I want to change the confidence level, it will change everything else automatically. So 1 minus, instead of writing 0.95, I just clicked on that cell and then press enter. Okay. All right. I have everything I need now to calculate that margin of error. Equals confidence. All right, as I start to write confidence, I'm seeing two different functions. I can see confidence.norm and confidence.t. Okay, let me scroll down so everyone can see that. So confidence. All right, so I see confidence.norm and confidence.t. Now, confidence.norm is for large sample sizes, right? So if I had a Z confidence interval, then I would use confidence.norm. All right. Confidence.T is when you have small sample sizes. Now, if you have a small sample size, which we do, so we're going to use confidence.T, you do need to make the assumption that your data is normally distributed. All right. So in order to use this confidence.T, or the T distribution, the student's T distribution confidence interval, you do need the assumption that this data is normally distributed. Okay. So the first thing it's asking me for is alpha. All right, so just click on that cell, 0.05. Next thing it's asking me for, so I write a comma, so it goes to the next one. Standard deviation. This is the sample standard deviation, so I'm just going to click on that cell. All right, and the next thing it's asking me for is size. Size is your sample size. So just click on that. All right, so I've just clicked on where the sample size is. I close parentheses, and I press enter. And there we go. I have the margin of error. All right. So next, let's calculate the lower side of the confidence interval. You might see that written as lower confidence limit. So CL, same thing. So type in equals. All right. Take the sample mean. So just click on that cell. Subtraction sign. Then the margin of error. So click on that cell where the margin of error is. All right. So the sample mean minus the margin of error. Press enter. Okay. And do the same thing for upper, except we're going to do a plus sign. Okay. So equals X bar plus this margin of error. Press enter. All right. So let's see what we got here. We're saying, we have 15... 27 or 15,270 to 26,838. All right. So it looks like I am 95% confident, right? Because my confidence level was 95%. I am 95% confident that the population mean price of cars is somewhere between $15,270 and $26,838. All right. And we can change the confidence level here. Say I were to do 0.99. Everything else will update because I've used formulas, right? Instead of typing in numbers, I've used 1 minus the cell reference, right? And then I've used cell references here. So everything updates automatically. And we see that 99% confidence is 12,7, let me write that down, 12,744 to 29,363. All right. So what we're seeing is as we get more and more confident, the interval is getting wider and wider, right? Which makes sense. It makes sense. if we need to be more confident that the population mean is somewhere in the interval, then we need a wider interval. The narrower the interval, as the interval gets really, really narrow, then we become less and less confident that mu is somewhere in that interval. Okay, so that makes sense. Wide intervals, high confidence levels. Narrow intervals, low confidence. All right. You might notice that the way I've calculated this Confidence.T, it uses the Excel formula, right? That margin of error tells you right away. There is a formula for margin of error, which I didn't really discuss here, but let me discuss it briefly for a second now. Actually, let me write it down here. Let me scroll down. Okay, so there's a formula, E equals T, the critical T value, times S over the square root of N. Okay, you could have used this formula instead of using Confidence.T. Let me show you just how to do that if we wanted to. You don't have to do it this way. Okay, first thing I'd want to start with is figuring out the T critical value. So equals T dot inverse dot 2T. 2T says it's a two-sided because our confidence interval has two sides. Okay, the probability, right, it wants this alpha level. The degrees of freedom, right, is always whatever the sample size is minus 1. So I'm just going to type in 9. Okay, so always your sample size minus 1. Okay, press enter. I'm going to go ahead and change this back to 0.95. All right, you see the T critical changed automatically. So it's whatever your alpha is, it's the probability, and then degrees of freedom is the sample size minus 1. Okay, press enter. All right, now I have everything I need to calculate the margin of error. So equals this T critical times the sample standard deviation divided by SQRT, that's the square root function, of the sample size. Sample size is 10. I could have just typed in 10, but I can use the cell reference as well. So I just clicked on 10. Close parenthesis and press enter. And you see this is exactly the same as this. All right. So this is basically Confidence.T is a shortcut way of, it kind of avoids using this whole formula. All right. But you'll get the same answer either way.